Welcome back, guys. Since we had a short break, I think we will not be able to have break. We'll just continue. So this is the second tutorial. I'm sorry, it is titled tutorial 1 again. This is chapter 2, right? This is chapter 2, and this tutorial is on quadratics. So we are going to look at a revision of everything we did on quadratic in this particular question. So we begin with the first question. Lina, did you attempt these questions? Lina, did you attempt the questions? Is her microphone on, or she's not getting me?
She's not getting you.
Madam.
Did you attempt the question?
Yeah, I tried 5.
Okay, you tried just 5.
My mic is on.
Yeah, but you did just 5. That 5 is not enough now. All right, since you tried 5, you'll be solving some, I'll be solving some, and Roger will be doing the rest. Are we together?
Yes, sir.
Yes, Lina, put off your camera. That is what's making your connection slow. Your camera is slowing down your connection. I don't know if she's getting me. At least she can see. All right, she has put it off. Oh, she has gone off. All right, so let's take this first question. Given that 2x squared minus 3x plus k is a perfect square, then the value of k will be if this is a perfect square, what would be the value of k?
So I had problem with this question.
So if this is a perfect square, this is what we will do to have the value of this is what we are going to. Yes. All right, Lina, welcome back. So we are about answering this question. For us to have this value of k here, this is what we do. We first of all divide all through by 2, such that we'll have x squared minus 3 on 2x plus
half k.
A certain number here, k, which is what we are looking for. At this point, for us to have this as a perfect square, this number here is given by, we take a half of this minus 3 on 2, and we square it. So this value here will be equal to minus 3 on 2 all squared. And what does this give us? This gives us 9 on 4. Are we together? Are we together? So our k is 9 on 4. Lina, is this understood?
No, I would stop you.
Is it okay? Lina, do you get me?
Yeah, Jacob, sure.
Yes, madam.
Okay. Now the second question, the function f of x equals x plus 2 all squared minus 9. This function has a minimum value of.
I don't like that.
So for us to have a minimum value of this function, we just look at it directly as it is like this. If you fit 0 here,
My aim is bad.
pardon? I don't know if she's even getting me. So this value here is the minimum value of this function. This value like this value is the minimum value of this function. This -9 is the minimum value of this function. So the minimum value is -9 when the function is in this
Now
form.
for yes. Yeah, answer me.
Lina, can you get me?
Yeah, good.
Yes, madam.
All right, let's look at the next question, question 3. Can you do this one?
The quadratic is a turning point and
Yes,
Pepe.
question 3, yes.
Where's open?
So when does a turning point occur for this quadratic?
It was more than Senna. No problem.
I'm getting a lot of noise from your background.
Listen.
Lina. All right, so for us to get the turning point here, welcome back, Roger. Sorry about your connection issue. So for us to have the turning point of this quadratic, what do we do? We already know that this -9 is the y value at the turning point. For us to have that turning point, we equate what we have in brackets here to 0. And this will give us x to be equal to, Roger, are you there?
Yes, I'm there.
-2 and y to be equal to -9. When we get to differentiation and curve sketching, we will see more about this. But when the function is given in this form, then this is how we get the turning point. We equate this, what we have here, that's completing the square method, x plus 2 to 0. And this one is the y value at the turning point, which is -9. All these values here, I'm sure these values here are 2. They're all 2s, not 1s. I thought they updated these things. There's no update. All right, so we have the values at turning points. You have -2 and -9. Equally, this one is 9. All right, because this function was edited. We had x plus 1 whole squared -4. I think it's a typing error. This function was edited to this one. Yes, I can remember. So we equate this one to 0. We have the x value, which is -1, and this one is the y value. So that's why you have -1 here and -4. But in this particular case like this, our turning points occur at -2, -9. Are we together?
Yes, sir.
Okay. Question number 4. The axis of symmetry in this question is, you can see now they're still using the same question here. This same one I've given like this, because this one was updated. So let us use this one for the question. So the axis of symmetry here will occur at what point? B, right? Yes, the course here. Just equate only this one to 0. Now let me go up a bit. As I've said, this is the function x plus 1. This is the function that it was updated to. I think they did not save the changes. X plus 1 all squared -4. So for this function, what is the axis of symmetry? Axis of symmetry, you just equate this value that we have in brackets that has been squared to 0, and you have x to be equal to -1. This is the axis of symmetry. I think we discussed these two in the notes. Why this one is the y value, which can be maximum or minimum. In this case, the minimum value. Is that okay, Roger and Lina? Any question?
No, sir, no, sir.
Okay, let us clear and go to the next.
Tu peux avoir ça. Oui.
Yes, madam.
All right. Do you have any question, Lina?
No, madam.
Okay. Now let's look at the fifth question. You are given this equation 2e to the power 2x plus 3e to the power x equals 2. What are the roots of this quadratic equation? Roger, did you solve this one?
No, sir, I did not solve this one.
Lina? So say let our x here, let e to the power
Yes, madam.
x. All right, let e to the power x be equal to, for example, t. This one is called a concealed quadratic, a hidden quadratic. So this one can be written, this e to the power 2x, the same like e to the power x times e to the power x, which is e to the power x all squared. So we'll have 2 e to the power x, all of this squared, plus 3 e to the power x minus 2 equals 0. But at this point, we have said, let this t be equal to our e to the power x. So we'll have 2t squared plus 3t's minus 2 equals 0. When you solve this quadratic, what are the roots? When you solve this quadratic, what will be the roots? All right, look for delta. Delta will be equal to b squared minus 4ac. B squared is 3 squared, which is 9, minus 4 times 2, 8, times minus 2, minus 16. So 9 minus minus 16 is minus is plus 25. So this gives us 25. And the square root of 25 is 5, right? So our t here will be equal to negative, that is minus 3, plus or minus the square root of 25, that is 5, divided by 2a. In this case, our a is equal to 2, so 2 times a is 4. So what will be the values of t? So t will be equal to minus 3 plus 5. Minus 3 plus 5 is minus 8 divided by 4, which is minus 2. Or we have t to be minus 3 minus 5. Or this one was minus 5, that gave minus 8. Now minus 3 plus 5 is plus 2. Plus 2 divided by 4 is a half. So at this point, either e to the power x is equal to minus 2 or e to the power x is equal to a half. But e to the power x can never be equal to a negative number. So this root, this one cannot be the correct root. We will not take this one because e to the power x is always positive. Therefore, we'll have our e to the power x to be equal to a half. And when we take ln on both sides, we'll have x to be equal to ln a half. And ln a half the same as ln 1 minus ln 2, which is minus ln 2. Roger, do you understand this one?
Minus ln 2.
Are we together? So this type of equation, first of all, understand that this is a concealed quadratic. Concealed means hidden. A quadratic that is somehow hidden that you cannot see it. But if we let this e to the power x to be equal to t or any other letter that you like, then these are e to the power 2x will be the same as e to the power x all squared. And we can now simplify this as a quadratic. We replace all the e to the power x by t's. And the discriminant of this is b squared minus 4ac, which is 25. And the square root of 25 is 5. So using the quadratic formula, we'll have t to be equal to negative b plus or minus this square root of 25, which is 5, or that on 2 times a, or that on 2 times 2, which is 4. So this gives us two values of t, minus 2.5. But we know that t is e to the power x. So we have e to the power x to be equal to minus 2. But e to the power x can never be negative. So we cannot take this value. Then we have e to the power x equals a half. So we take this one. But we are looking for x. So we take ln on both sides. We are taking ln on both sides because the base here is e. If it was 10, we can take log, or any other number, we can take log. So x is equal to ln 1/2, which is the same as ln 1 minus ln 2, but ln 1 is 0. So we just have negative ln 2. That's why our key here is D. This one is a good one now. Hello? Roger has gone off again. Lina, are you there?
Yes, madam.
Is this understood?
Yes, madam.
All right. I hope you are prepared for the quiz on Friday.
Yes, madam.
All right, or otherwise you're getting prepared. Yes, I saw your question that you sent to the group, and I showed that what you have to do is to square both sides, right? Are we together? Yes, Lina, are you getting me?
Yes, madam.
Lina, you're having a problem because your microphone is, because your camera is on. You need to put off this camera that I'm seeing like this. Your connection will be going normally. You can see yourself here, right? It's because of this camera that is on that we are having connection issues. It is taking up a lot of megabytes. So anytime you want to start, don't start with your camera on. Always reject. Start only with audio. Do not start with video. Yeah. All right, let's just go ahead. Question 6. We have this quadratic equation, this. Let me clean this board. So we have the quadratic equation that has roots m and n, where 3m is equal to 4n. The value of k is. So how do we get the values of k? The value of k. We know that each quadratic x squared minus 14x plus k equals 0 has been written or can be written in some product form. In this case, if the roots of this quadratic are m and n, then it therefore means that here, this minus 14 is our sum of roots. So here are m plus n, m plus n is equal to 14. Do you know why n plus n is equal to 14? Do you know why? Hello?
No, madam.
Right, because normally you do not attend the last classes, that's why you have difficulties. Now, whenever I have a quadratic like this, x squared minus 14x plus k, this quadratic can be written in some product form as follows. You have x squared minus the sum of roots, x plus the product of roots. So plus the product of roots is equal to 0. And the condition here is that the coefficient of x squared should be equal to 0. If it's not equal to 0, then you have to divide all through by whatever number is in front of this x squared. So in this particular case now, you see that this is our sum, because minus sum is equal to minus 14. And our sum here is m plus n because the roots are m and n. So minus 14 is equal to minus the sum. So m plus n, these minus signs will cancel out, and we are left with m plus n is equal to 14. Why the product of roots m times n will be equal to the product of roots here is equal to k. But you have been told in this question that 3m is equal to 4n. So you can use this idea. 3m is equal to 4n. So I can use it in this first equation here, and this will give me, instead of writing m, I'll replace m by 4 on 3n. So we have 4 on 3n plus n is equal to 14. Lina, do you know where 4 on 3n is coming from?
Yes, madam.
All right, so it is coming from this, what has been given from the equation, that 3m is equal to 4n. So I can make m the subject of the formula here, and m will be equal to 4n on 3. So if I now substitute in this first equation, we will now have 4n plus 4 on 3n plus n is the same as, using fractions, that will give us 7n on 3. This for the left-hand side should be equal to 14 on the right-hand side. And when you solve for n here, what do you have, Lina?
N is 6.
Good, n is 6. And what will be the value of m?
M will be. Okay. M is 8.
Okay, m is 8. Now the value of k, we know that k is m times n. So what will be the value of our k here?
48.
Thank you, 48. So our key here is D. Thank you very much. It will be good that after this, you try to answer these questions again. It's very important. Yeah, it's very important. Then, question 7. Did you attempt question 7?
No, madam.
All right, let's look at question 7. So with question 7, we have the equation x to the power 3 plus 3x minus 5 equals 0 has roots lying in the open interval. So with this one, you don't need to solve anything. You just need to test. They're asking if this equation has a root in this first interval, this second, this third one, or this fourth one. So we have to test. An equation will have a root in an interval AB if f of A, let me write it like this, f of A, this A is the first number. Like for example here, either these 2, when you're using 2 and 3, or this 0. When f of A times f of B, B is the second number, when that product is less than 0. If this occurs, because you can say you should prove that this equation or this polynomial or this function has a root in the interval this to this. And this is how you do the proof. You look for f of A, look for f of B, and get the product. If the product is less than 0, then it has a root in that interval. Otherwise, it does not have a root. So let us start by testing with this first one. So this first one, 2 to the power 3 is 8. 8 plus 3 times 2, which is 6. 8 plus 6 is 14. 14 minus 5. 14 minus 5 is 9. So we have 9 times, let's take 3 now. 3 to the power 3 is 27. Plus 3 times 3, which is 9. 27 plus 9, what does that give us? 36. 36 minus 5 is 31. So 9 times 31 is equal, this number is greater than 0 now. So this is greater than 0, right? Because this number is positive and the second one is positive. Are we together?
Yes, madam.
This one, the root cannot be this interval because our result is greater than 0. It will only be in the interval where our result is less than 0. Now let's test the second one. If we fit 0 here, we'll just be left with a -5. -5 times, when x is equal to 1, this will give us 1 plus 3, 4 minus 5, which is negative 1 again. Negative times negative is positive. So this number is still greater than 0. So this cannot be the interval where the root is found. If we test for 1 and 2, we will have, the first one will be negative. When we put 2 to the power 3 is 8, plus 6, 14 minus 5, 9 is positive. So we have the first one positive, the second negative. So when we do this product, our result will be negative. So this tells us that the root is in this interval. Is this one understood?
Yes, madam.
Yes. And when they say a root is in that interval, means if you have something, this is A, for example, and this is B, and this is a number line, means that the graph passes somehow like this. This is your f of x rather, means that the curve passes somewhere like this between A and B. It cuts the x-axis. They will say it has a root in this interval. And if it does not have, then this interval will be outside. All right, let's take number 8. Let's take number 8. When you attempt the questions before class, we go faster. Otherwise, we'll be taking much time, which is not an advantage. So the roots of this quadratic px squared minus qx minus r equals 0, if these roots are real, then what's the condition for the roots of a quadratic equation to be real? Do you know about the discriminant? Lina, are you there?
Yes, madam.
So for this equation to have real roots, then the discriminant written like this, b squared minus 4ac. Do you know b squared minus 4ac, right? Yes, should be greater than or equal to 0. This is the condition for real roots. We are being told that we have 10 minutes left. This is the condition for real roots. Yes, our class has really extended. So this is the condition for real roots. Now, our B here is this negative q. So in this case, we write it as negative q squared is q squared minus 4 times a. Our a here is p. And our c here is negative r now. So PR, but the times negative, now this one becomes positive. This should be greater than or equal to 0. So which of them matches this condition? B.
B.
Yeah. B.
Come later.
All right. Your connection is really disturbing today.
Yes, it's too disturbing.
Yes, mine has also been disturbing so much. Some days are just like that. Anyway, I'm recording this one. Last one, the other ones, it was not uploaded. I checked because I'm not the one to upload. I just know it was not uploaded. I'll really lay emphasis on it again. I'm sorry about that. Okay. Now let us look at the question number 9. Question 9 is on identities. This is one of the topics that we'll do next week, as I've given the announcement in the group. So for question number 9, we have x squared minus 4x minus 1 is identical to this. Then what are the values of b and c? To get the values of b and c, you just expand the right-hand side. This will give us x squared when you expand.
Plus 2bx.
Plus 2bx. Plus b squared. plus C. This for the right hand side, right?
Yes, sir.
All right, so if
Yes,
it's
sir.
identical to this, then the terms in X, we bring them together. Those in X squared, you bring them together. In this case, the coefficient of X squared is 1. Here, the coefficient of X squared is 1. So they're identical. That's okay. And then the terms in X, we have only this one. So we have 2bx to be that is plus 2bx is equal to minus 4x. In that case, our 2b's will be equal to minus 4. And what will be the value of b?
B will -2.
B will be equal to -2. Lina, is this okay? Well, Lina has gone off to now with connection.
Yes.
And now this b squared plus c should be equal to -1. Beta b is -2, so you have -2 squared plus c equals -1. All right, plus c equals -1. So what will be the value of our c? C will be equal to -1 minus 4, which is -5. We answered this question in class, I can remember.
I'm not sure, sir.
Okay, so our b is -2 and our c is -5. So we have d. Yes, Lina, welcome back. Your connection is also disturbing. Eh? All right, now question number 10. Question 10, the quadratic this has sum of roots. What's the sum of roots of this quadratic? Okay. Lina, are you there? So what's the sum of roots? Lina, Roger?
So,
So the sum is equal to the negative of this value that is here. So it will be negative of -2 on 3. And this gives us 2 on 3. Roger, is this clear?
it's okay, sir.
Yeah. Lina, is this okay?
Yes, madam.
Okay.
Uh,
All right, let's look at question 11. Question 11, we have the roots of the quadratic equation, this are they real and equal, real and distinct, imaginary, or both negative?
Real and equal.
All right, let's look for the discriminant. The discriminant to tell us everything. So the discriminant is given by b squared minus 4ac. B here is -3 squared. That gives us 9 minus 4 times a. That's 4 times 2 times c. That's times -1 now.
Yes, sir.
So this gives us 17, which is greater than 0, right?
This is greater than 0.
and this is strictly greater than 0. So what can we say about the roots? The roots are real because this one is positive, they are real. They are not equal because this one is not equal to 0. So they are real and distinct. They are real but different. All right, question 12. This quadratic has an intercept on the ordinate of. What is the ordinate? Which axis is called the ordinate?
The x-axis.
I gave a formula now. There are two axes. You have the x and you have the y. The x is called the abscissa and the y is called the ordinate. And what is the rule I gave? X comes before y, a comes before o. So the ordinate axis, or the ordinate for short, is the y-axis. So, and the ordinate, on the ordinate, the intercept there is called the y-intercept. The y-intercept occurs when x is equal to 0. So just fit 0 in this equation. What will be the answer?
Negative.
No, just fit 0 here and just forget about the right-hand side.
Negative 6.
Forget about the right-hand side. Just fit this f of x. Forget about that one, that right-hand side. So you fit 0 here. Yes, we'll be left with just because this will give us 0. This also gives 0. We'll be left just plus the positive 6.
Minus 6.
Are we together? You can see the result. The key here is D. All right, please, guys. You try to answer the remaining questions so that we can discuss them in the next class or discuss on the WhatsApp group. I'd like to see your answers there. Our time is up, and please answer these questions from 13 to 50 before that class because some of them will come in the quiz. Are we together?
Okay, sir.
All right. And for you, Lina, you can always visit the blog here to get the questions and everything you need. The notes and everything is here. If you cannot access it, ask in the group. Ask in the group where you are, and they'll give you the link. Thank you so much, and nice day. All right. Goodbye, Roger. Goodbye, Lina.
Okay, sir. Goodbye.